So, what is the Kakutani fixed point theorem? It's a question that might sound intimidating, but today we are going to break it down, and by the end of this video, you will have a clear picture of this fascinating mathematical concept and why it's useful. So just keep watching the video and we are going to talk about it. The Kakutani fixed point theorem is a generalization of the more well-known Brouwer fixed point theorem. If you are familiar with the Brouwer fixed point theorem, you know it says that for any continuous function mapping a compact and convex set to itself in an Euclidean space, there is at least one point that remains unchanged or fixed. But Kakutani takes this idea one step further. So imagine you have a set of choices, a menu of options in a restaurant, for example, but instead of one definite choice, each time you choose something, you might actually be choosing a whole set of options. So instead of a single dish, you are presented with the possibility of all main course or all side dishes. It's a bit abstract, but Kakutani's theorem works with these kinds of multi-valued mappings. And now here's the technical side. The Kakutani fixed point theorem applies to functions that don't map single points to single points, but rather map points to sets of points. Specifically, if you have a closed, convex, and compact set, and a function that maps each point in the set to a closed subset, Kakutani's theorem guarantees there is at least one point that maps to a set containing itself. This is our fixed point. To get a feel for this theorem in action, let's take an example in economics: market equilibrium. Think of a market with several buyers and sellers. Every player in this market has a set of strategies or choices, like the price to buy or sell at, or the quantity to trade, for example. Each player's strategy depends on others' choice, the choice from the other players, and so their best response form a set and not a single point. With the Kakutani fixed point theorem, we can prove that there exists a stable state, the equilibrium state, where no one wants to change their strategy because everyone is in his optimal outcome given everyone else's choice. This is the concept behind Nash equilibrium, which itself relies on Kakutani's fixed point theorem. Now let's make this more visual. Imagine a square, and each point in this square can move, but only to other points within the square. The rule here is that each point moves to a set of points, maybe all the points along a line, or even a small region around it. The Kakutani fixed point theorem might seem abstract, but it's a powerful tool. It's fundamental for economics, especially for proving the existence of equilibrium. Beyond economics, it's useful in game theory, optimization, and mathematical modeling, where interactions are complex and outcomes aren't single decisions but entire sets of possibilities. So, the next time you hear about equilibrium in markets, Nash strategy in games, or any system where players make decisions within a complex interactive set of choices, remember the Kakutani fixed point theorem. That's all for today. Hope you liked the video. Don't forget to hit the like button because it helps me a lot. And also, don't forget to subscribe to the channel so you can know when I upload the next videos. See you guys in the next video. Bye!